In the depths of the cosmos, beyond the stars and galaxies, lies a question that has haunted humanity for centuries. Does the universe have a boundary? What lies beyond it, if anything? It's a question that pushes the boundaries of our imagination, tests the tenets of our knowledge, and invites us into the unknown. The universe is a huge expanse filled with stars, galaxies, and unsolved mysteries. It's a place where we've marveled at the beauty of the cosmos, explored distant planets, and pondered the origins of everything. But here's the question that has intrigued scientists and philosophers for centuries. Is there a limit to the universe? What lies beyond it, if anything?
In the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
We look around the universe and it looks like we're in the center. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here or return to this spot a billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
To understand whether our universe has a boundary, let's start with the Big Bang. It's widely accepted that the universe began with this colossal explosion, but what happened afterward? Around 13.8 billion years ago, the universe was a singularity, an immensely hot and dense point. Known as cosmic inflation, the cosmos rapidly expanded from this singularity. The universe grew dramatically throughout this time, becoming significantly larger in a split second. Fundamental particles like protons, neutrons, and electrons formed when the universe cooled and expanded. Later, these particles came together to form atoms, mostly of hydrogen and helium. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form. This event, known as recombination, led to the release of photons that had previously been trapped by charged particles. Over billions of years, gravity caused matter to clump together. These clumps of matter eventually formed galaxies, stars, and planetary systems within galaxies. The conviction that Earth was the center of the universe and that there was a physical limit to the cosmos once reigned supreme in the annals of human history. This geocentric viewpoint argued that our Earth plays a central part in the cosmic dance of stars and planets. It was supported by ancient philosophers like Aristotle and Ptolemy, and was strengthened by the Church during the Middle Ages. This worldview was firmly established in philosophical and theological traditions, as well as being a scientific idea. It helped to spread the idea of a finite universe when combined with the lack of telescopic technology. Humanity's path from Earth's alleged centrality to our knowledge of an expanding and perhaps limitless universe is a magnificent odyssey of discovery in the grand cosmic story. Astronomers like Edwin Hubble's groundbreaking work fundamentally altered how we view the universe. Hubble made a groundbreaking discovery in the early 20th century while methodically observing far-off galaxies. Galaxies were not static in space, but were instead moving apart. The Big Bang Theory, which revealed the universe's profound origin some 13.8 billion years ago, was created as a result of this key observation. That's not all, though. Scientists had to consider the notion of the universe's unlimited size as they probed the mysteries of it more deeply. Picture the universe as a vast cosmic fabric woven with galaxies, stars, and planets. The unsettling part is this: the fabric isn't stationary. Instead, it's stretching and expanding over time. This means that the galaxies and celestial objects within it are all moving away from each other, like dots on an inflating balloon. Everything we are aware of, including the Earth, the Sun, and even ourselves, is traveling endlessly across the cosmos. The universe is always changing, despite the fact that it frequently seems to be an eternal backdrop to our life. But it goes further than that. Concerning issues regarding the ultimate future of the cosmos, are brought up by the idea of cosmic expansion. According to some hypotheses, this expansion might go on forever, resulting in a big freeze scenario in which the universe turns into a cold, lonely expanse devoid of life, warmth, or hope. The mere thought of an infinite universe is almost impossible for the human mind to fully grasp. It confronts us with the idea that there might be no ultimate boundary, no edge, and no limit to the cosmos. This incomprehensible vastness can make us feel infinitesimally small and insignificant in the face of an endless expanse. Our knowledge of the observable cosmos is a great testament to human curiosity and scientific investigation, but it also emphasizes the size of what is still unknown. We have seen galaxies, stars, and other cosmic occurrences inside the confines of the observable universe, which is a limited area measuring 93 billion light-years across. There are numerous mysteries yet unsolved, even within this observable domain. For starters, we've only scratched the surface of cosmic exploration. The number of galaxies, stars, and planets in our observable universe is staggering, and we've studied just a fraction of them in detail. There are entire galaxies, distant cosmic corners, and uncharted celestial objects that await our telescopes and spacecraft to reveal their secrets. The observable universe is estimated to have a radius of approximately 46.5 billion light-years, which means we can see objects that are up to 46.5 billion light-years away from us. This includes galaxies, stars, nebulae, and other celestial objects. There is a cosmic horizon in the observable universe, which is essentially a line that we are unable to see past. The universe's limited age, 13.8 billion years, and the speed of light are what define this barrier. We are currently unable to observe anything beyond this horizon, since it has taken too long for their light to get to us. Imagine you're in a car, driving down an infinitely long, straight road that stretches through a vast, uncharted desert. You're on a mission to reach the edge of the universe, which, in this analogy, represents the ultimate cosmic boundary. As you accelerate, the road continues endlessly, with no visible end in sight. You drive for days, weeks, and years, but the road ahead never seems to change. It's as if you're trapped in a surreal cosmic highway where the horizon remains eternally distant. Here's the twist. The faster you drive, the more the road stretches ahead of you. It's as though the universe itself is playing a cosmic trick on you, ensuring that the edge remains forever out of reach. You come to realize that no matter how fast your car can go, you'll never quite reach that elusive boundary.